Hello, Math 7 students. Today we're going to get started with how to find the sum and difference of fractions with unlike denominators. So in 4.3 you did like denominators, and now we're going to look at unlike denominators. So alert, before you add or subtract fractions, be sure you always have, and I know you've heard this multiple times, you must have common denominators. Okay, and then we're going to actually use, sorry, I ran out of space. We're going to use this example to walk through kind of your steps in solving a problem with unlike denominators. So the first thing we're going to do is find the least common denominator, or kind of like the least common multiple of those denominators. So the first thing I would do is list the factors, or not the factors, the multiples of 10 and the multiples of 2. So the multiples of 10 are 10, 20, 30, and so on. And I'm just going to stop there. And then for 2, I know my multiples of 2 are like 2, 4, 6, 8, 10, 12. And then once you see that least common multiple or least common denominator, which I've seen, it is this 10. They both have that 10 in common, and that's the smallest number that they have in common. We know that that is going to be our least common denominator. So then what we want to ask ourselves is, how do I get from our current denominator so that I now see a common denominator? So because of that 10, the 9/10, I know that 10 is our resulting denominator for that first fraction. So I'm just going to go ahead and keep that 9/10. But then for that second fraction, I'm going to bring down the plus sign. I have -1/2. So to get that 2 up to the least common denominator of 10, I'm taking 2 times what to get us to 10. So you can also see right here that it's the 1, 2, 3, 4, 5th number in kind of my pattern, or those multiples. So I'm going to multiply the denominator by 5, but whatever you do to the denominator, you must always do to the numerator as well. So I'm going to multiply that fraction by 5 over 5. So my new fraction is going to be -5 over 10. And notice that I've put that negative up in the numerator because remember, we want common denominators. So if you put that negative down in the denominator with the 10, you would not have that same denominator. So I went ahead and just kind of pulled this negative and I put it up into the numerator. So now that you see it's 9 over 10 plus a -5 over 10. So for step 3, we're going to just add or subtract the fraction. So yes, I see that it's an addition sign, but if I have a 9 plus a -5, we know from last chapter that we need to use that different signs, because one's a positive, one's a negative. We're going to subtract them and keep the larger. So then I'm going to take 9 minus 5. I end up with 4. The larger is positive. So my answer here is 4/10. But I'm not yet done, because right here it always says we must simplify. So to simplify this fraction, I know I could just divide by 2 in both the numerator and denominator because they're both even numbers. So I end up with 2/5 as my final answer here. All right, so looking at that example, kind of keeping that in mind, we're now going to practice, and we're just going to do 4 quick problems together. And then on the back, you're actually going to do just 4 quick you-try problems. And then your notes for day 1 will already be finished. So for example 1, we're going to find the sum or the difference and write the answer in simplest form. So 5/8 plus 3/4. I know that I first want to, based on my steps above, find that least common denominator. So I'm going to list out the multiples of 8, and I'm going to list out the multiples of 4. And most of you can already see this, and you don't necessarily have to show this multiples, but I like seeing it because I know it goes 8, and then 8 times 2 is 16, and 8 times 3 is 24. Same with a 4. 4 times 1 is 4. 4 times 2 is 8. And 4 times 3... Oh, and I could even stop because I see that my least common multiple is 8. So I'm going to get those denominators so that they're both 8. So 5/8 I don't have to do anything with because we already have that 8. And then right here for the 4, I'm going to multiply it by 2. And whatever I do to the denominator, you want to do to the numerator. So plus, and this turns out to be 6/8. And then when I add those two things together, I end up with 5 plus 6 gives us 11/8. So you can leave it like this, but I also want to quickly talk about how to turn an improper fraction into a mixed number. So our improper fractions, you're just going to put that numerator under the divisor. or it's the dividend, and so then you're going to put 8 outside. So now you're just going to physically divide it out. So how many times is 8 going to 11? It goes in once. So 1 times 8 gives us 8. 11 minus 8 gives us 3. So that final answer as a mixed number would be 1 whole. So I'll put or. 1 whole. And then I have my remainder of 3 that's going to go up in my numerator over that original denominator of 8. So yes, you can keep this as the improper fraction, but just as good practice, if I were you, I would also show it as a mixed number, just so that you can prove to your teacher that you know how to convert from improper to mixed. All right, we're going to move along to example 2. So here for example 2, I see my denominators are 6 and 4. So again, I'm going to list my multiples of 6. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18. 6 times 4, 24. 6 times 5 is 30. And then now also for 4, I know 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. Oh, there we go. Because I see both numbers have that common denominator, that common multiple of 12. So now I'm trying to get that the denominator for both of these fractions to be 12. So I know that I want to multiply 6 times 2 to get 12. Whatever I do to the denominator, you want to do to the numerator. Same thing with 4. 4 times 3 would give us 12. So then I'm going to rewrite my new fractions. So negative 2, and remember, I'm going to put that negative up in the numerator. So negative 2 over 12 plus, and then I have 3 over 12. So once you have those common denominators, you're just going to simplify the numerator. So it's really like I'm just doing negative 2 plus a positive 3. So again, this is a DSL problem. Different signs. We're going to go ahead and subtract them. 3 minus 2 equals 1. And then I keep the larger, which was this 3. So I know I end up with 1/12 as that final answer right there. All right, hopefully we're still feeling pretty good. We're going to move on to example number 3. And if I am going too fast, remember you can always pause, you could rewind, you can look back at that example to make sure that your work matches mine. But these are your notes, so make sure they're making sense to you, and you're not just writing them down just so that you have them down, so you get your points in the grade book. All right, moving on. 2/3 plus minus a negative 3/5. So I'm actually going to start by looking at those signs. Whenever you see that minus a negative, hopefully that kind of big plus sign comes into mind, or that additive inverse. You would change that minus sign to a plus sign, and so that negative becomes a positive. So really all I'm doing here is just adding my two fractions. So 2/3 plus 3/5. Okay, but again, we must get that common denominator, so I'm going to list out my multiples of 3, and I know that it's 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 12, 15, 18, and I'm going to stop for now just to see if maybe I can already see for that 5. I know 5 times 1 is 5, 5 times 2 is 10, 15, oh, there it is. So we see that both 15 are multiples of 3 and 5. So then I'm going to say, okay, I get 1, 2, 3, 4, 5. So I'm going to multiply the 3 by 5. So my new fraction over here is 10 over 15 plus, and then 3/5. I know that I'm going to multiply by 3 to get to 15. So I now have 9/15. And then that's really just an addition problem. So when I add these two things together, I get 19/15, or let's go ahead and practice turning this improper fraction into a mixed number. So if you could go ahead and pause and try and write this as a mixed number, and then push play when you have that correct, or when you have that answer to check your mixed number. All right, hopefully you ended up with 1 4/15 by saying 19 divided by 15. It goes in one time. 15 with a remainder of 4, so 1 4/15. All right, moving right along to example 4. Uh-oh, this one looks a little bit more intense. Right here, I'm going to start with what's in the parentheses. So I'm going to treat this like a totally separate problem. I know that my common denominator is going to be 6 because I know I multiply this 3 by 2 in order to get that denominator of 6. So really I just have 5/6 minus 4/6. Now remember, this minus sign, this like kind of floating minus sign, we don't want to deal with subtraction problems. So instead, I'm going to use that additive inverse. So I'm going to add this. And so therefore my second fraction becomes a negative. So now with those common denominators, I know that denominator will always just stay that same denominator. I'm never, ever, ever going to add those denominators together. So you have 6 down in the denominator, and then up in the numerator we have 5 plus a negative 4. So if you were to do a quick scoreboard, we have 5 positives, 4 negatives, so I know my positives win the game by 1 point. So my answer here is 5/6, but I'm not yet done because I have that other fraction that I still have to deal with. So plus 7/8. So notice I'm just using that plus sign right there. So then here I need common denominators again. So I'm going to list out, so 6, 12, 18, 24, 30. I'm going to list out the multiples of 8. So I have 8, 16, 24. There it is. So I see both of them have 24 in common. So I'm going to multiply this 6 by 4 to get 4 24ths. Okay, plus, and then I have 7/8. So I'm going to multiply the 8 by 3. So I have 21 24ths. So then when I add these two things together, that's just adding the two fractions. So I end up with 25 24ths. Or again, as a mixed number, I would take 25 divided by 24. It goes in one time with a remainder of 1. So I would also have 1 and 1/24 here. All right, hopefully you feel pretty good. Let's go ahead and turn over our notes. All right, so back here, you are going to work out these examples 5 through 8 on your own, and then push play once you are finished, because I'm going to provide you with those answers as well as the work so that you can see if you got them right. Well done. If you got them wrong, you can kind of check my work to see maybe where we might have made that little mental math error. So go ahead and pause, and once you finish those 4 problems, go ahead and push play and check your answers. All right, so looking at example 5 and 6, notice for example 5, I have 9/20. If you got that incorrect, go ahead and look through my work to see maybe where we went wrong. And then for example 6, I end up with -43/30 or -1 and 13/30 for example 6. Also, if you're listening to me right now, right in between examples 5 and 6, kind of smack dab in the middle of those two problems, I want you to draw yourself a Christmas tree. Okay, it's almost Christmas time. We know we're excited to see that Christmas time, that Christmas break, to spend time with our families. So go ahead and draw a Christmas tree just right in between those two examples. Doesn't matter how pretty it is, but I just want to make sure we are listening here. All right, so for example 7 and 8, let's look down below at those two. I'm going to quickly work those to make sure that you have your correct answer. All right, looking at example 7, we got a final answer of 9/10 because I just made a big plus sign right there. And then for example 8, I first needed to start inside of the parentheses, and that simplified expression under those, or in those parentheses, gives us 1/35. And then I still need to add that to 2/5, so then I need common denominator again of 35. I got 15/35. That simplified answer is 3/7. All right, so I want you, also if you're listening right now, I want you to answer this summary portion, and your teacher will check your summary once they get around to checking your notes. So go ahead and answer. How is adding and subtracting fractions different from multiplying and dividing fractions? They just took a quiz over. So go ahead and answer that question, and good luck on your problems.